In this lecture, I'm going to focus on the distance formula, specifically the concept of the distance formula. And when I say the distance formula, I'm really talking about the distance between 2 points on a plane. And that basically means 2 points on a piece of paper. How do you find the distance between them? There's a few prerequisites that are kind of not so obvious. A lot of people think it's very easy to find the distance between 2 points on a plane, but really there are a few prerequisites here. You have to know about radicals and roots. You also have to know how to solve radical or rational exponent equations. Either or, doesn't really matter. And then finally, you really do need to know the Pythagorean theorem, because that's the basis of the distance formula. So I'll start with a theorem for the distance formula here, and this is a conceptual theorem, so there's not really a formula given, and actually this theorem itself is going to be a lot more wordy than the actual real theorem. But I like the idea of conceptualizing or visualizing what the distance formula is. So let's say we got a couple points. And I'll illustrate this by actually just graphing a couple points on a coordinate system here. So let me throw out a coordinate system and plot out a couple points. Let's say that this point is x1 comma y1, and let's throw this point over here and call this x2 comma y2. Okay. So I have a couple points there on a plane. And this says that the distance between these 2 points can be found by determining the horizontal and vertical distances between the points. Well, what the heck does that mean? It means find this distance right here all the way out to, let me kind of do this here. So I want to find this horizontal distance in red, and then I want to find the vertical distance here that's in green. Now notice, by the way, that the horizontal and the vertical line, like all horizontal and vertical lines, meet at a right angle. Okay. So I'm going to find those horizontal and vertical distances, which I say are actually like a delta x. Delta, remember when we talked about slope a long time ago, delta means change in. So a change in x, and delta y means a change in y. So we have some change in x here and some change in y. We're going to use those two distances and the Pythagorean theorem to allow us to find the distance between these 2 points. And if you recall the Pythagorean theorem just says leg squared plus the other leg squared is equal to hypotenuse squared. So that's what we're going to use. This is, and I'll call this the hypotenuse here. So we get a right triangle when we do this. When we go horizontal and then vertical to get to the other point, we get a right triangle. And in this case, we could easily see, oh, this tells me that I'm going to take that change in x and square it. And to that, I'm going to add the change in y squared, because those are the 2 legs of the right triangle here. And that should equal the hypotenuse squared. So I'll write that in there, hypotenuse being squared. In fact, I'll put that in parentheses as well. Great. So that is the conceptual definition or theorem for the distance formula. We just are making a right triangle and saying change in x squared plus change in y squared should equal the length of the hypotenuse, or in other words, the distance between those 2 points squared. Of course, you should be able to take the square root of both sides and say, therefore, that means that, and I'll write this just in blue, that the hypotenuse itself should equal the square root of the change in x being squared plus the change in y being squared. So that should be pretty obvious to us right now. But let's go ahead and try an example. And I know this is the conceptual lecture, and usually I don't like to do examples in the conceptual lecture, but let's do a simple example just to see how this works. Let's find the distance between -3, 5 and 2, -4. I'm going to draw a picture of this real quickly just so that we can kind of get a visualization of what's going on here. This will be my x-axis and my y-axis. Let's go back 1, 2, 3 and up 1, 2, 3, 4, 5. So this point right here will be negative 3 comma 5. And then I'll go forward 1, 2, and down 1, 2, 3, 4. So this point right here will be 2 comma negative 4. And I want to find the distance between those 2 points. Now, as I said, what we want to do is find the vertical change here. So how much change do we experience in the y direction? And then find out how much change we experienced in the x direction. And that will give us actually a nice right angle. And if you connect these two lines up, which kind of might be difficult because I'm freehanding this, but if you connect those two lines up, that should give us a right triangle actually, and this would be the hypotenuse of that right triangle. So we have some change in y here, and we have some change in x here. Let's see what that change in y is. Well, let's see, the y value for this upper point is 5. The y value for this lower point is a negative 4. So let's see, I have 5 units above and then 4 units below, so that should be a distance of 9 units. So the change in y is actually a distance of 9 altogether. There's 5 units above, 4 units below. The change in x, let's see, the x value here started at a negative 3 and ended at a positive 2. So the change in x here should be, well, the 2 plus the 3 should be 5. So the change in x should be 5. So let's find the length of the hypotenuse. And as we said in the conceptual example here, is we could just use the Pythagorean theorem. You do not have to actually start with the square root. You could say the hypotenuse squared should equal leg squared plus the other leg squared. You could do it this way. That's absolutely fine, because then you find the hypotenuse squared should equal 81 plus 25. Or, in other words, 106. Yeah. Well, that's the hypotenuse squared, so that means the hypotenuse itself should equal the square root of 106. Now, for those who know that it should be plus or minus the square root, I'm just telling you right now, a length cannot be negative, so it's just going to be the positive square root of 106. We cannot simplify this radical because it just simplifies into root 2 times root 53, which can't simplify any further, so it's going to be the square root of 106. That's the distance between those 2 points. So that's taking this from a conceptual point of view. For those who know the actual distance formula and have memorized it, I really prefer that you don't memorize a distance formula. Instead, you just know that, hey, it's the Pythagorean theorem. That's all it is. So that it's one less thing that you have to remember. Now, in the next lecture, I'm actually going to go and introduce the distance formula. But again, I'm going to tell you there as well to not memorize it, but instead to use the Pythagorean theorem. It's just much easier to use the Pythagorean theorem.